sum of squares, and for this we have the definition formula and the computation formula. The definition formula is easy to understand because if we have, you know, n observations and we calculate the mean, this is how we calculate it. One is the average. Then we can take the distance from the mean of each data point, the xi, and well, we need to square it, otherwise we would get values cancelling out, and we can just sum them. So that's the definition of sum of squares. But it's often easier to calculate it this way, that I take the data points and square them and sum them up, minus I take the sum of the data points and square that up, so these two are rather different, and divide by n. Okay? The question is that why are these two the same? So it's like why are they the same? That's the question we are asking. And here is the proof. It's just a simple calculation. The idea is that we start from the definition formula and we end up with the computation formula. Okay. So I will, of course, simplify it a little bit. So instead of writing that the sum goes from I equals 1 up to n, I will just say that, okay, what we have here, we are summing over the data points, and I is used for that. So this is the data point xi, and this is the mean squared. Okay, and at this point, we don't need to worry about it. This is just, you know, a minus b squared. So this is elementary algebra. So let's do that. Summing over, but it's like, you know, I can forget about the sum and just look at this expression, and this will be xi squared minus 2 times xi times the mean plus the mean squared. And that's the same. I'm still working inside the parentheses. What I'm going to do is just extract x, the mean of x. Okay, so it's the sum I, and I have xi squared minus the mean extracted. So this will be, well, let's write it that way. So we have the mean minus 2 times xi. Okay, one more. So at this point, we can get rid of this parentheses, the outer level, because we are summing over, and this is a sum as well. So we can do the summing separately. So that will be summing up the squares of the data points plus I can, you know, just extract x squared. Oh, yeah, it's there was a mistake here. That's a plus, so I fixed that one. Anyway, so I extract the mean, and then do the summing. that will be the mean minus 2 times xi. Okay, so that thing has been fixed. And now, well, it's okay, I'm done with this part. This is already what's in the computation formula. So I just have to show that the mean times the sum of the mean minus 2 times xi is actually the same as that. So we need to continue. Well, of course, I have to write this down as well. Okay, plus. So now I'm looking at this expression. So I know that I'm summing, I'm adding up in n times. You know, this is I equals 1 up to n, and that's just a constant. So this will be just okay, let's put it into parentheses. It will be n times the mean minus 2 times the sum of xi's. Okay, so that is the same as, well, I have to write this one down. Okay, plus that one, and minus 2 times the sum of those. Okay, now what we need to do is to actually bring back the definition of the mean. Up to this point, we just had x bar, the mean is just calculated. Is okay, that's just a number. But now I'm going to use the definition of that. So this will be the sum, the xi's divided by n times n. Okay, I'm doing this. Times the sum of xi divided by n. Minus okay, well, it's another mistake here. Well, I still have the mean there. It was there. I just forgot to write. Okay, so minus 2 times. It's the sum of xi is divided by n. Okay, that's the definition of the mean, times the sum of xi. Okay, now a bit of simplification. We can simplify by n there. So what do I get? This is the first part. It's just fine. So then I'm going to get so plus the sum of xi multiplied by itself, so we square that, divided by n. So I have that, and to subtract twice, well, that's the same thing, sum of xi squared divided by n. So what do I get? Well, I have this squared, and well, looking at this whole thing, this is the same, and I add it once and subtract it twice. Oh, therefore this is just that. Okay, since I added once, subtracted twice, and that's actually the computation formula. This is what we wanted to have. Okay, so just look back. This is a good practice for calculating with the summation formula. So the goal was to show that the definition formula of the sum of squares and the computation formula, they are the same. So what we did, we started with the definition formula, which is easy to understand. We did just the algebra, a plus b squared. Okay, here we have xi and minus the mean of x. So we did that, and then we extracted the mean from that. Yeah, I'm just checking. Okay, well, I swapped the order here, and that's why I got confused with the sign as well, but now I think it's fixed. And we continued. We just realized that, well, if I just sum a constant, that's just n times the constant. Okay, and we get to this point where we use the definition of the mean. And once we have the definition of the mean, we just simplify and actually get the computation formula. And that's the proof that they are indeed the same.